So we've got 3.1 electric circuits homework, and the first question states the circuit shows battery, 9-volt battery connected to 2 ammeters and a lamp. It's 0.6 amps through the one, so what's it going to be through the other one, the first one? That's the first question. Pretty much says that. You have to underline it. Well, we know that SCS, so in a series circuit, the current is going to be the same. I think that's what it is. My iPad's just playing up a minute. I think it's because I had it plugged into the mains. So, SCS, series current, same. We can do this little table now, just in case we do forget this. So I've got current is the same there. If we know it's the same in a series, then the current is going to be adding up in a parallel, so it's going to be split. And then voltage is the same in a parallel, so it's going to add up in a series. Okay, the voltage there. Using the correct symbol, add a voltmeter. Well, I've done that across it, so I can't put a voltmeter in series. A voltmeter must be connected in parallel. The reason I've gone up and not down, I could have brought it down. So I could have brought it down like that, but then obviously the writing is in the way, so that's why I didn't do that. So let me undo that there. Boof, boof, boof. And then the next bit says the voltmeter reads 9 volts and the current through the lamp is 0.6. This is a really easy equation. I doubt if we'll get anything this easy on higher. But I've done the triangle anyway, so VIR, because we're dealing with voltage and we're dealing with current, and it's looking for resistance. So that's all I would do. It's hard for me to show my finger on this, but I would cover R with my finger. Once the R is covered, you got V over I. So V over I. So R equals V over I. You probably get a mark for that if that wasn't given to you. And then you just replace the values then. So we got 9 volts, it says there, and you got 0.6 amps. Okay? And that comes out to be 15 ohms there. Just right there. Then it says, state what happens to the current through A1 when the 9-volt battery is replaced by a 12-volt battery. So the current's going to increase. If you add more voltage, voltage is kind of directly proportional to current, especially in fixed resistors at its constant temperature. So as you increase the voltage, the current is going to increase. State what happens to the current through A1 when another lamp is connected. Well, when you add another lamp, it's going to decrease, and it possibly could decrease by half, depending on the resistance of that amp. Sorry, not the amp, the lamp, sorry. So if you add another exactly the same lamp in, it's going to half. It's going to decrease. And that's that page. So I'm going to put that up there. Homework 2, a lighting scheme is being planned for a new restaurant. Information about the light is shown below. So position of the lights over the tables, in the toilets, in the kitchen. Number of lights, so they want 20 lights over tables. 6 lights in the toilet, 6 lights in the kitchen. Description of the lights, so they want these 11-watt fluorescents over the tables. They want 18 watts in the toilets, giving a little bit more light. And then in the kitchen, they need lots of lights, so they're going to use these 50-watt fluorescents. All the lights will be connected in parallel to a 230 volt main. So I've underlined that. It's possibly going to be helpful to know in the coming questions. It says give a reason for connecting lights in parallel. Well, there's 3. It's only worth, let's have a look. How many is it worth? It's only worth 1 mark. But there's a possible 3 answers here. So I said the same voltage across each lamp. So when you do it parallel, the voltage is the same. So you get the same voltage across each lamp, which means it's going to be the same brightness. They can also be switched off with switches. So they're easily manipulated. You can't do that in a series. And if one bulb breaks, and I haven't put it here, if a bulb breaks, it's not going to break the circuit. So the other lights are going to be able to stay on. Use an equation, so this is more likely what you're going to get in higher. Use an equation from page 2 and 3 to calculate the mains current flowing through the light-in circuit when all the lights are switched on. So really, we need a power equation here, and the power equation from your page is going to be power equals I times V, or PIV. And if we're looking for current, then we need to have P over V. So if I put my finger over I, it's P over V. If I replace these values, now the power, the total power, you need to add up 11 watts, 18 watts, 15 watts, and you've got 20 of those, you've got 6 of those, and you've got 6 of those. So that's what I've done there. So 20 times 11 plus 6 times 18 plus 6 times 50, that's where I've got those from. Okay, and then all over to 230 volts, which it tells me there from the mains. And that brings my current out to be 2.73 amps. And then regulations for the circuit mean that the power loss in the main supply cable should not exceed 19 watts. So what it's saying is that the cable they're using cannot hold more than this power. So use an equation from page 2 and 3 to calculate the maximum resistance, because obviously they want to know which cable to use. That's the maximum power it can hold. So what's the maximum resistance it can take? Now when we've got power and resistance, okay, and we already know our current, then we can use that equation, which is P equals I squared times R. This is higher. And then we can put it into a triangle. Remember, anything that's times stays together. So I squared and R stays at the bottom, and P goes on top. If I'm looking for the resistance, I'm going to cover R, and it's going to come out to be P over I squared. Well, your power's 19, it says there, 19 watts. And your current is 2.73 there. And then, but we need to square that. And when we do that, so I did it, what I should have done is showed you how I did it. So it would be 19 over the answer to 2.73 squared. So that's just 2.73 times 2.73. And that equals 2.55 ohms. And that's what I've written there as the answer. Again, picking up lots of marks here. Calculate resistance for each fluorescent light used in the kitchen. Now this was a little bit trickier because we didn't really know the current going through each, because it's a parallel. If it was series and we know current was the same everywhere, that'd be fine. We could just use that. Because we're dealing with a parallel, I hope I said series before that. Because we're dealing with a parallel circuit now, and it tells me that up the top, there, we don't really know the current going through each of these. So we're gonna first of all work out the current by PIV. So if I cover I, it's got power. The power is 50. We know that from the fluorescent light there. Let me just wave that there. And we know that the voltage is 230. It's said up here somewhere, didn't it? Let's go back up. I underlined it. Yes, 230 volts. So I can then put the power over the voltage, I equals P over V, and to come out to 0.22 amps. And now we can use this in my resistance equation now. So now I know I also know V, so I can just use VIR. And the resistance, if I cover R, it's going to be V over I, and then 230 volts over 0.22 amps, which I just calculated is going to be 1045.5 ohms. Could have rounded that to 1046 there. This is 9 minutes already, so I'm going to probably make this my last question and then do another video. So it says the diagram shows a lamp connected to a battery and a variable resistor. Well, you notice that, oh, what happened there? You notice a variable resistor when you've got that sort of arrow going through it. And usually the more you increase this, the more resistance it will bring about. So the first question, I'm guessing, is to describe how the circuit is used. So this is a 4 marker. So describe how the circuit is used to obtain a series of measurements. So this is your standard circuit that we really want to test Ohm's law with. You should add the symbols to the circuit. So the voltmeter needs to come across the bulb in parallel, because voltmeters are added in parallel. And then I've got that ammeter, and I could have stuck that anywhere in the circuit so long as it's in series. And then we just need to say what we do. So we would literally set the variable resistor either to minimum or maximum setting. So we'd either slide it down or slide it up. And then as we change the resistor, we would allow the fixed values for voltage. So what I mean by that is once I'm bringing that resistor up, I'm maybe going to bring it to allow 1 volts out. I shouldn't say out there. 1 volts to be pushed through. And then I'm going to take an ammeter reading. So at 1 volts, I'm going to take an ammeter reading, and then at 2 volts, I'm going to take an ammeter reading. At 3 volts, so your voltage is your independent there. It's the thing that we're changing all the time, and your current is the thing that we're measuring. So we're measuring current against voltage. So I've said there, change the resistor to allow fixed values for voltage through the circuit, and then record the values for current. Now it's 4 marks. You probably get a mark for those, and you mark 3 marks for that. So 11 minutes. I'm going to finish there, and then I'm going to come back with, and let's write it so I can do this. So I'm going to come back with part 2, Lush. So part